Thank you. Thank you. So my name is Marcin. I'm a solution architect for Oracle Cloud and specifically for high performance computing. I'm also a maintainer of our Oracle Cloud HPC automation. So an automated clusters for the marketplace where users can just deploy automatically clusters to run their workloads. And this is also something that will be providing you an access to the clusters deployed in this particular way. And I'll talk about it later. And I'm here to answer all your questions. Sorry, it's been a lot of meetings today. So yeah, I'll start with the introduction, very quick introduction to Oracle Cloud. Who are we, what do we do, and a little bit more about the HPC specific elements of the cloud. And then just show the architecture for planned architecture for a student cluster competition, a little bit of hands-on how to log in and how the console looks like, what you will have access to, and then I'll be more than happy to answer questions. So HPC is a big part of our Oracle Cloud offering. We build our HPC solution as a first-class citizen, not as an afterthought of selling servers to run a bookstore. We built our global environments as a hyperscale regions with networking that it's not oversubscribed, it's fast and has predictable latency. Our clusters have 1.5 to 3.5 microsecond latency between the nodes, and this is something we can guarantee and promise. We have 36 regions right now, and more to come. In multiple regions, we are actually connected directly to our colleagues in Azure, so the users can also connect their Azure OCI environments if possible. And here it is, why we are better in HPC than other cloud providers. We do offer bare metal compute, and this is the biggest point. You get full access to the hardware as you would in your own data center or on your desk. We were first really to offer a bare metal in a hyperscale cloud environment. We have better price performance than other cloud providers, and it's basically the same as you would run them yourself. Our HPC systems have local NVMe storage, so plenty of disk space and ultra-fast disk space for your workloads, and block storage that it's at the lowest cost and the highest performance among the cloud industry. What is interesting, the IOPS are not you don't have to pre-provision your IOPS or buy them specifically. They're always there. You always get the specific number of operations per second and predictable throughput. And hey, we are in a top of the list of IO 500, thanks to my colleague, who's our parallel file system expert. And those are also deployable now on Oracle Cloud with a single click. So it's pretty cool. Our RDMA network is non-oversubscribed, flat, 100 gigabit Ethernet. So it's a Rocky V2 networking for RDMA. We do offer network performance SLA, not that it's much of an interest here. And also the front-end networking is non-oversubscribed and up to 100 gigabit. In the systems that we will be providing you, it's 50 gigabit regular layer 3 network. We offer 3 different compute choices for as the servers. So bare metal, So direct access, no hypervisor. OS is directly installed, connected to the machine. It is block volume, so iSCSI attachment to the system. You get the server for yourself. You don't share it with anybody. So no jitter, no noisy neighbors, and no CPU credits that you can spend. You get a full performance from the machine. We also offer virtual machines. So the regular multi-tenant VMs with a fairly lightweight hypervisor, so not much overhead, not much performance loss due to the hypervisors, and the hardware is can be para-virtualized, but also can be accessed through these. So networking can be accessed without any performance loss. We do also offer emulated virtual machines, which are great if you're running a legacy OS, the MS-DOS or Windows 95. You can run them if you want. And the third option is dedicated virtual machine host, which is hypervisor running on bare metal that it's dedicated for the user. So you run your VMs without sharing them with anybody else. So you get full isolation and also flexibility of the VMs. We offer currently 4 different types of machines. So Intel, AMD, Ampere, ARM machines, and of course the GPU-based servers. In the student cluster competition, we'll use 2 of the ones presented here. So it will be bare metal optimized 336. It's a brand new Ice Lake Xeon 3.6 gigahertz all-core turbo with 512 gigs of RAM and 3.84 terabyte of NVMe storage. It has 2 50 gig NICs for the front and the 100 gig RDMA Rocky V2 connectivity. And the other type that you will get access to is bare metal GPU for 8. This is basically a supercomputer in a box. It's 8 NVIDIA A100s, 2 terabytes of memory, and 27 terabytes of NVMe storage, 16 100 gig RDMA interfaces, so 1.6 terabit of RDMA network performance, and it's running the AMD EPYCs as a CPU. For the login node, you'll get access to the VM optimized 3 Flex with 8 cores. It's the same system as bare metal optimized, just in a VM shape. So you will have 8 CPUs and 128 gigs of RAM. We also offer Ampere virtual machines and AMD. You can test actually AMD and Ampere in our always free tier. If you want to play with things, you can sign up for Oracle Cloud always free account. You get $300 to spend, and then always free. You get 2 AMD machines or 8 ARM cores that you could use in any shape or form you'd like. So, cluster networking, up to 20,000 core clusters can be built using this technology. Low latency, high bandwidth, no sharing of bandwidth with anybody else. We try to place the host in the same block and as close to each other as possible to minimize the latency effect on the system. It's scalable. You can increase the size and decrease. You can increase and decrease the size of the cluster live, and you can run also multiple clusters at the same time. Yeah, this is technology to run your RDMA workloads in the cloud in dynamic way anytime you want. For storage. So as mentioned before, you will get access to local NVMe. On every compute nodes, you will have between 384 to 27 terabytes of NVMe storage. You will also get a block volume attached to your login node, a 1 terabyte high performance block volume. Block volume is an iSCSI attached storage, so your typical storage area network environment. If needed, we can provide you access also to an object storage, so think S3 or Azure Blob technology if you need to store a lot of files. I did mention that before, so for bare metal optimized and GPU 4.8, you will have your NVMEs. Block volume. So you get consistent high performance from the block volumes, and they are persistent and durable. So they are backed up. So if something goes wrong, you can restore from the backup, and you can attach 32 block volumes per instance and up to 32 terabytes per volume, which gives you, you can scale up to 1 petabyte of storage per instance if you want to. You can attach also block volume to multiple instances at the same time, but your file system needs to support, so you would need to run Lustre or something like that to be able to utilize that. Our block volumes are split into multiple performance tiers that you kind of, you can change those tiers live if you want. So if you're running a commercial deployment, right, you can run a higher performance during business hour and lower performance when there's less users connected. But my suggestion is for the architecture, we will deploy high performance volume, 1 terabyte volume, so 50,000 IOPS, and 1 terabyte storage. So this will be about close to 500 gig per second. File storage service, it's there. It's NFS as a service available to mount for files. It's not super high performance. You can get about 600 megabytes per second read write at the same time per mount target. Mount target is basically an IP address that you expose in your network to mount the file system. It is a managed service. You pay only for what you store, right? It shows up as 8 exabyte file system, but you pay only for what you actually put there. So to the actual clusters that they will be deploying, 1 VM optimized 3 flex, 8 core for the login node. So it's an Intel Xeon Ice Lake 3.6 gigahertz all core turbo. We will deploy 4 bare metal optimized 336 nodes for compute and 1 GPU 4.8, so 8 NVIDIA A100 GPUs for GPU workloads. 1 terabyte of block storage exported from login node, but you can switch that, or we can just attach it and not mount it if you prefer to do so. 6.4 terabyte NVMe storage per compute node. That's a mistake actually on my part, sorry. It's actually 3.8. 6.4 is for the previous generation. This is exported as NFS Scratch as well from a single node if you need like faster file system to share the files between the nodes. So like a local, like a shared Scratch file system that you would normally use for a CFD workload. All those NVMe disks are mounted and under MNT local disk. We can change that. And also there will be a single server deployed in a central location that will export NFS team number mount point for every team to upload the resulting files. So here is the diagram of what we're proposing. We will have one central location, a central network, what we call a VCN, virtual cloud network, with 2 subnets, a public and a private. And this kind of reflects as well each team's network assigned. The central location will export NFS from management node to every team network. All those networks are connected to a central location through a local peering gateway. So team 1 can access central and team 2 can access central. Central can access all team locations. There is no traffic between team 1 to team 2 to team 3. This is isolated. So for your safety, for your to not have anyone prevent you from running workloads or trying to interrupt you. You will get a public subnet and a private subnet. Public subnet will contain your login node, so we'll get a public IP address for your login node and an SSH key to access it. And from there, you can access your compute cluster. All your compute nodes will be available there. Compute cluster also has an internet access through a NAT gateway. So if you need to download files from the internet, pull some libraries, anything you want, you can do it through the NAT gateway. And here's a little zoom in into the actual cluster. So the login node connected to the public subnet, 4 compute nodes and the GPU node connected to the private subnet, and the 4 HPC nodes connected to the RDMA network. GPU node is not connected over RDMA to the compute nodes. It's a separate entity. Okay, so this was the presentation. This is my whole pitch. I'll show you a little bit of something more interesting, an access to the console and how the environment actually looks like, if I can find the Zoom sharing screen. So here is the Oracle Cloud Console. You will get your own user. Each team will get its user, so you'll be able to see your compute nodes. You will be able to reboot them if something goes wrong. You will be able to attach a serial console to each server as well. So if something goes wrong, if your boot volume is bad, your OS is misbehaving, you will be able to troubleshoot it or restart the node if you have to. Each team will be isolated into a separate compartment, what we call a compartment. So you'll be able to see only your servers and access only your servers. So as you can see, the login node, we call a bastion. You get a public IP address and you can use it to log in over SSH with the SSH key. There is no password access by default, but you can configure it. There is an LDAP server running as well on the bastion node. So if you need multiple users, you can create them through LDAP. We do not currently submit the metrics from the HPC nodes. So you want to be able to see your CPU utilization in the console. You need to monitor them internally. You can install Grafana or something like that to monitor your system. To reboot the node, here's the reboot button. You can go ahead and click it. You have also an option. This will be an ACPI reboot, so graceful shutdown of the instance if it's completely dead and you don't want to wait for 15 minutes before it will reboot because it's not responding at all. You can click the force reboot button and it's basically pressing a reboot on the chassis. You can see your attached VNX, so you can find your IP addresses and MAC addresses here, and you can create a console connection for each of your instances. You upload your SSH key. And create local connection. And when this is created, you can click on copy serial console connection. And you'll get basically a string that you can paste in your terminal window and access the serial console. You can also use VNC. This will create an SSH tunnel to the port 5900 on the instance on the hypervisor or management card of the server, so we can actually access the UI directly through the internal connection. This can be quite useful if you're troubleshooting something. The login is very simple. Just copy your public IP address from the console, and we will provide it to each team as well. And just SSH, provide a key. And we can log into the system. From here, you can check the host file. You will see you have 5 nodes. The node number 5 is your GPU node. You can see the name is central GPU something. So you can actually, for each team, the name will be something like team number GPU, and you will be able to access your GPU node. This environment is deployed in central, so we use central-GPU, and we can see our 8 NVIDIA cards here. Each node is deployed in with a number. So we have 4 nodes, HPC node 1, 2, 3, 4. You can use those names. You can change them if you want. There is plenty of Ansible playbooks available on the system, on the Bastion in OPT, OCI, HPC. You can find playbooks that you can use it as an example to configure things or reconfigure system. You can just run Ansible playbook site YAML in this directory to reconfigure system from scratch, basically, to make sure that everything is as it was in the beginning. You can install a scheduler or anything you want on the system. This one actually already has a scheduler installed. This is my fault, but by default, it won't come pre-installed, but it's easy to install. And if you want, there is already an automation for scheduler built in. You can check your Ansible inventory and use multiple configuration options here to reconfigure the system. Autoscaling will not work. The system will not have permissions to access the autoscaling, so you will not be able to increase the size of your cluster beyond what is deployed. Okay. I'm happy to answer any questions and show things that you might be interested in. That might be the best way for us to proceed.
Thanks very much, and for the demo especially. We have had a few questions have arrived in the Google Doc and in the chat, all of which have gathered answers, but I think it's good to vocalize them so that everybody else can make sure that others have seen and heard them. So I'll go through and you can add comments as you please. So the first question that was asked was, if the parallel file system on Oracle Cloud is faster than the competitors, will IO 500 be allowed on Oracle Cloud? And the answer provided was no. IO 500 is not allowed on Oracle Cloud.
Not in this environment, yes.
Yeah. How many CPU cores total and how many GPU cores again? So I see you had a slide about that. And I think we'll actually be posting the slides later on the website. Is that correct?
Yeah,
we can do that.
I will send the PowerPoint or PDF with the slides afterwards.
Cool, but somebody has provided the answer here of so one VM with 8 core for login node, 4 by 36 nodes. Is that 36 cores, I guess, for compute nodes, and 8 by A100 for GPU nodes?
Yes, for 36 core machines, there are 36 core 72 thread machines, and yeah, and the GPU nodes, they are 64 cores in addition to the 8 GPUs.
Sounds good. So there was another question: what is the cost of one of the student clusters? And with the answer, if this is a question about budget, the Oracle Cloud part of the competition isn't constrained by a budget. You'll be given the nodes that were in that spec to run on.
It is not constrained by a budget.
Was that my internet that froze or Martin's?
He looks frozen
it's
to
margins.
Yeah, I think it's Martians.
But yes, the answer is, so it's there is no budget for the students, right? So the students will get the cluster for the duration of the competition, this cluster that's specified on the second question. And so here the issue is getting the best performance or getting the challenge done with the cluster that's provided.
Mary Thomas here. So I was the one asking about the budget. So Louise or Steve, so we will get a cluster, and then the students will have to configure it, install the software, install the scheduler, and be ready to get all that done. I take it at the start of the competition, and then run with the system that they've designed and configured themselves for the duration. We won't be starting and stopping different VMs like we would be doing with Azure.
That's correct. So you will be given the plan is we will set up 2 clusters right now.
Luis. Hi, Luis.
Sorry,
this is Kathleen.
Yeah.
Yeah. Let me handle this question.
Okay.
So hi all. This is Kathleen, the chair for the cluster competition. We are going to be sending out an email to all of the teams to have you guys be scheduled for when your training time will be before the actual competition. So please look for that email and let us know when we have that out so that you guys can get access to these systems. We have to get it scheduled so that it's kind of split up across the different weeks.
Thanks, Kathleen.
And to complement, this is for the training. During the competition is what Mary mentioned. So each team will have 1 cluster, and the cluster will be configured or set up, and you have the cluster for the 48 hours of the competition. You don't need to spin new clusters, new images, I mean images if you want, you can do that, but you don't need to deal with VMs or things like that. It'd be as if you had brought your own hardware to the competition.
Okay, thank you.
Yeah, I apologize. My power went down for a second.
Oh, that's unlucky. Good that we've got you back there. Thanks. So just summarizing what Lewis was saying as I'm writing it into this doc so that we can kind of keep a copy of it for others to watch later and to rewatch. So the cluster will be set up by Oracle before the competition. The teams won't need to do the setup. Did I interpret that correctly?
That's correct. That's correct. Or, I mean, the teams are free to terminate those clusters, or if if it's a request, they don't want to have a pre-configured clusters. It is also an option. We can provide an example resource manager scripts, which is a Terraform plus Ansible code that we use to deploy those clusters, and they can modify those things as well. I see the question regarding Cloud Init. So if we pre-build those clusters, well, Cloud Init is not there. But if you want to do so, we can again provide you a zip file. There is an option to include the Cloud Init in the zip file that you use in a resource manager. From our side, we would prefer to pre-deploy those clusters. It's easier for us and probably less problems and less questions during the whole thing. But there's nothing preventing teams to not use that. The interconnect is a Rocky V2, so it's Ethernet. It's basically Ethernet with the Mellanox CX5 100 gig cards. The Rocky, for those who don't know, it's RDMA over converged Ethernet. The version 2 of the protocol is using UDP encapsulation for RDMA for InfiniBand emulate traffic. So it's using a regular InfiniBand verbs over Ethernet encapsulated or UDP encapsulated traffic. Rocky V2 brings what is called a routable Rocky. So it operates purely on a layer 3. Or not purely on layer 3, it's layer 4 encapsulated, but it's routable across the subnets. So yeah, we do not offer pre-configured nodes with Ubuntu. So yeah, if you want to run Ubuntu, what we can do is we could deploy the cluster with Ubuntu, but it won't be configured at all. And it will not come with any drivers, anything that it's required to run on Oracle Cloud. And there is one thing that I did forgot to mention in the presentation. So cluster networks requires an authentication. It is somewhat automated. It's taken from a instance metadata. What do we call it? An identity metadata. It's basically a certificate chain inside the queryable metadata of the instance that needs to be submitted through WP supplicant. So in a way, it's the same way you would authenticate to your Wi-Fi network or 802.1x corporate enterprise secure Ethernet network. We do that for isolation between the environments, right? Between the users, so they cannot snoop or intercept or interfere with each other's traffic. We can provide you with a deb package for that. But you would need to install your own Mellanox OFED drivers and everything, pre-build them into your environment. Oracle Linux is binary compatible with Red Hat Enterprise or CentOS. The packages are interchangeable. So if you have packages that are built for CentOS or Red Hat, you can use them on Oracle Linux without any problem. The repositories are there, and including the EPEL repositories as well are available in Oracle Linux. So we have plenty of package options to choose if you need some extra libraries. Drivers for the GPU are already installed in the GPU image. So we provide NVIDIA 470 driver, the latest driver in this image. Again, if the team wants to run Ubuntu, they will need to install NVIDIA drivers separately. And we will provide in a kind of a welcome information or a document for the teams. We will provide a typical flags that we use for MPI traffic. There are a few flags that provide a an optimization for Oracle Cloud with OpenMPI and Intel MPI. I can probably just share the link to the blog post from my colleague that describes all the flags for popular MPI implementation. We do not have flags for MVAPitch. So if you're using MVAPitch, we can help you figure it out, but we haven't worked much. We just started our conversations with the MVAPitch team.
So thank you, Imagine. I'm still catching up a little bit on jotting the answers there. But so that was, so you have flags pre-configured for MPitch, but not MVAPitch.
We have for Intel MPI and OpenMPI and Platform MPI.
So
Right.
there is
So,
a, oh, I'm sorry.
Oh, sorry,
There's
go
a question at the end. If the team trains on a specific cluster, will they get to work with the same cluster? The answer is no. So the cluster for training, so you get the same configuration, but it's not guaranteed that team A practices on one cluster and will get that same cluster later on. So basically you get the clusters, let's say, from scratch at the time of the competition.
Okay, so that's the heart of my question is in a normal in-person, when you bring a cluster, you've spent months configuring it, getting the software right, et cetera, for the particular applications. So in this case, we'll have to consider how much time is needed to install any specific software and tools that our team wants to work with.
Exactly.
Okay, yeah, that's an interesting way to emulate the in-person part of it. Okay, thanks.
So as a solution architect suggestion, automate as much as you can.
Yeah.
We speak stack.
Exactly.
That's a good bumper. That's a good bumper sticker right there.
Yeah.
I did see there was a question, why isn't the entire competition on Oracle Cloud? And I hope that's coming from a place of excitement for OCI. Kathleen, do you want to give some background on that?
Yeah, I'll take that question. So both Oracle Cloud and Azure Cloud are supporting the cluster competition. And so that's why we have two different clouds. It's also, we've been doing kind of new and exciting things every year, right? There's power outages. Sometimes you get a windfall of extra credits for Azure. And this year, because we were trying to add the power components for, the in-person teams, and also we have two different great cloud providers who are supporting us. We have both of the cloud providers supporting all of the teams now.
And as an extra bonus,
this is a good. Go ahead, Steve. Go ahead.
I was just going to say, as an extra bonus, having two cloud providers supporting us, means that teams have got more resources to use.
Yeah, and then what we see a lot with our customers too is, while we would prefer them to be our only cloud provider, multi-cloud is a reality. Hybrid and multi-cloud for organizations, especially large enterprises, is a reality, right? So as students, being able to kind of familiarize yourself with different platforms, different providers, different OEMs, and the nuances between all of those is only going to be better for your careers and what you can help bring to an organization to keep them nimble and moving fast and forward.
And for the cluster automation, I can send you all a link to our GitHub repository. You can take a look at what we do to spin up our clusters. And if you want, you can fork it and start from there.
That's a good tip.
I wasn't lying when you I said you got one of our best essays for this. Marcin is the man. And he's also in the Slack channel for the SCC student competition. So if you guys have questions, please feel free to, reach out. We're here to answer questions and make sure you guys have a good experience and a successful experience in the competition and the weeks leading up to it during your trial time. So if you get stuck, the docs pages are very useful. We've got a lot of good blogs out there. We've been trying our hardest to put content out there to be able to answer their own questions, but some things, as we all know, the devil's in the details, right? So some things aren't in the blogs, aren't in the docs, and maybe buried on a GitHub page somewhere. So if there's something that you're just completely stumped on, please feel free to reach out and help you get unblocked as fast as we can.
The other thing to mention is that we will have essays from different geographies, basically checking the Slack channel. So we should be able to, I understand the competition is 48 hours running. So we have people in Singapore, people in Europe, and people here in the US that will be monitoring that. So we will try to be a 24/7 response on this Slack channel.
That sounds great. So yeah, keep active on Slack teams.
Yeah, we all kind of live on Slack. It's whether you like it or not. It's whether you wish you could just, you could wish you toss your phone in the Mississippi. You'll still hear the chirp in your sleep. If I wasn't laughing, I'd be crying. So
we live on Discord as well, so I'm jumping between Slack and Discord and Slack and Discord and email.
It's a great tool, but it never stops. But it's good to see. I'm glad to hear there's excitement around this. We're extraordinarily excited to be a part of this. A lot of us have been in the HPC space for a long time. And Louise, you came from AWS before this, and before that, Cray. I was working at a reseller selling HPC into Boeing and Ford, and used to work at Boeing before that. And so, we just pulled in some of the Boeing chief architects for their HPC solution over to Oracle. And, for us to be a part of this competition and to support you guys is, it's really cool. I've gone to SC numerous years. I've always felt like the SC community has kind of been like my like extended family, right? So it feels kind of cool to be able to give back to this, and not just to be able to say like, oh yeah, we had X number of presentations, we got X number of badge scans, we did, this, and we spent this much money on dinners. It's like, no, I feel like we're actually doing something for the community and for the students and for, actual SC moving the ball forward for everyone. So it's a really cool opportunity for us, and we're very thankful to be a part of it. And we really hope you guys have a good experience, because, we want to be everywhere for you.
And we're very thankful for Oracle's involvement in the competition too. We're looking forward to it.
If there's no other questions, I think I'm. You're too good. You're gonna make me cry. Don't you cry, because I'll cry now. If there's no other questions, I'm good to end early. I know we're always kind of double, triple booked these days.
Yeah, I was going to say, it looks like the rate of questions is slowing down, and we have collected up, I think, most of the questions and answers in the Google Doc. So we'll make those kind of available along with the video recording of this meeting and the slides afterwards. Just before we do
Steve,
finish up,
there's one question that's not answered.
did we miss one?
Do we get to work with our cluster before the competition, or do we have to configure it at the beginning? So I think, okay, so that's the one that I answered, right? So you had one will be able to practice with the cluster with the same configuration before the competition, but at the competition, it's not guaranteed that you get the same cluster. In fact, my understanding is, Marcin, you are going to clean up everything, right? From in between practice.
In between practice, my suggestion is we will tear down the cluster and recreate it again. So there's no leftovers.
that's also a good thing. Don't leave anything on the cluster thinking that you're going to find it later on, because even in between practice, because that's not going to be the case.
Yes, that's very important to remember. Make sure you save everything. So just before we do finish up, Kathleen made some kind of important announcements about what to expect and looking out for emails. Do you want to just quickly repeat or summarize that, Kathleen?
Yeah, definitely. So yeah, just a reminder, I'll be sending out an email shortly for the teams to let me know we're going to be scheduling you guys to have your training session on the Oracle Cloud. And oh, one more announcement. If you could please make sure that you update your Slack profiles so that it says what team you are on, whether you're a student or an advisor. That would be greatly helpful for us when we're trying to answer questions and put things into the FAQs.
Yes, good point. That does help a lot. Okay, thank you again.
Can I ask again? I want to make sure I'm really clear on the timeline. In the next week or so, we'll maybe find out that we'll get some information on the training and schedule a training session with the committee and the Oracle Cloud representatives. And then we'll be able to work on and practice on training clusters before the actual competition. And then at the competition, we restart with a new cluster that we'll configure. Will we be able to work on training clusters up until the competition?
That's correct.
Okay.
So, but there will be a schedule, right? So we will set up a number of clusters, and Kathleen, maybe again, I'm jumping on the email that Kathleen will send. But so the short answer is yes, you'll be able to. There will be a schedule. You'll be able to sign up for the schedule. The clusters will be available for the next 4 weeks.
Okay.
And
so Luis,
yes,
let me give one small correction there. Every team will not have 4 weeks to run on their training
correct.
cluster, right? So Luis, can you confirm each
Yes.
team will get 4 days total, and we will be scheduling them over the next weeks?
Exactly. So yeah, we are not going to set up 10 clusters right now. We are going to set up a few clusters, and this cluster, and there will be a schedule, and people will sign up for that. But these clusters that will be set up will be available till the competition. So we need just to finalize the best way of doing that, which that's what we're going to work with Kathleen and team. But you should have access. Our target is, in fact, to start having access by Monday, and until the weekend of the competition, and that's when you're going to practice. The one big difference that I see is that, as Marcin showed, right? So it's pretty much, you don't need, my experience in different place was just setting up a cluster was some work. In this case, you will be given, setting up the cluster for us is much simpler, and still you will be given the cluster already there. So it's more of a matter of installing what you need and running with that. So I don't expect that you spend a lot of time during the competition basically figuring out the clusters. Just as I said, is as if you had your own system over there. Of course, you have to, or let's say, as if you have receive the brand new system and just go install things and get running. So that's the line of thought.
Thanks, Luis. So yeah, some good advice to the teams. As much as you can, use the pre-configured system and prepare your automation to install the additional software that you need. Because you will be on a tightly time constrained.
Can I, sorry, I didn't mean to interrupt, Steve. Can I ask a question?
Yes.
Brian Chin. So I'm just thinking about the scheduling of this. I had two questions, actually. One is, I assume the goal is still the highest performance and not, if you're given 4 days, how much work you can get done in 4 days. It's still what's the highest performance you can achieve.
The 4 days is for training.
No, I mean, during the competition.
During the competition.
Because we're not constrained by budget anymore. So I'm wondering, well, what is it? What's the objective that the students should be striving for?
The students will be trying to complete the science application problems that they're given, as well as talking to judges for their posters and doing the benchmarking. Although the benchmarking will be on Azure, not on Oracle.
Right. But
So specific tasks.
Yeah.
Okay. But are they being, so on the particular applications that we're going to run in Oracle, is it what's the highest performance you could achieve, or how many of the things could you get running? Or I'm not sure I still understand what you're.
So I'm planning, I think, one of the tasks for the Oracle for the Cardioid application, and I'm going to have them run a bunch of jobs that all have different requirements due to scaling reasons, and assigning points on how many of those they can finish, and then they have to answer questions about, based on what they've just learned about running the code, what would it take to actually make a cluster that would deliver results in a clinically relevant time frame.
Okay, great, thank you.
And as for the other application that we'll be running on the clusters, this will be the reproducibility challenge application. The instructions have already been posted on Slack and can also be found in the announcement FAQ Google Doc, so you can take a look there. We've also posted a test data set as well as a rubric that we'll be using to grade the reports that result from these from the benchmarks that we're going to ask you to run there. So you can take a look at that now and do some of it ahead of time.
Thank you. And I had one more question, if people don't mind. I don't want to.
We have about one more minute, and then we'll need to wind up.
So about the scheduling, the 4 days, I'm a little concerned for my students because they have 4 days, and I don't want them spending 4 24-hour periods practicing. In addition to the time they'll be spending in the competition. Is there some way we could consider, like, you get a day here, a day here, a day here, instead of like 4 24-hour periods?
That's a line of thought. We are just figuring out if a day or 2 days. So that's the final details that we have to discuss with Kathleen and figure out. But you are correct. It's not going to be like, it's a 4 contiguous day and that's it. You are the view is more like to spread these over the next 4 weeks, so you can not overload everybody on a single week or a single time, and then get some time to think about and then come back to the cluster and do some more stuff and things like that.
Right. Thank you.
All right. Thank you all for participating, and thank you especially Machin, Andrew, and Luis for answering lots of questions there. Watch out for the email from the committee, and good luck in your preparations.
Yeah, like I said, let us know on Slack if anything pops up. And Marcin, thank you again for walking through this with everyone. You're the man. Appreciate it. Kathleen, thanks for keeping us on track too. I know you're doing a lot of herding of cats here, so I appreciate it. And Steve, thanks for being our MC. And then where will students be able to find this recording afterwards in case they want to go over it again?
We'll post it. There'll be a link there's a webinars page at the Students at SC or the SC21 website. under
Perfect.
students and student cluster competition. There's a webinars page. We'll post it there.